Greetings to all. This is Dr. M. Maheswari, Assistant Professor of Information Technology, Bishop Weber College. Today my lecture is on machine learning algorithms. So in today's agenda, we're going to see about the introduction, the basic introduction of machine learning, and we're going to learn about supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, ensemble learning, neural network, and instance-based learning. So the basic introduction of what is machine learning. So learning algorithm in many applications that we make use of daily. Every time a web search engine like Google is used to search the internet, one of the reasons that works so well is because of learning algorithm that has learned how to rank web pages. So these algorithms are used for various purposes like data mining, image processing, predictive analytics, and etc. And to name a few. And the main advantage of using machine learning is that once an algorithm learns what to do with the data, it can do its work automatically. So the basic definition of machine learning was coined by Arthur Samuel, that is, machine learning is defined as the field of study that gives computers the ability to learn without being explicitly programmed. So the machine learning relies on different algorithms to solve the data problems, and data scientists like to point out that there is no single one-size-fits-all type of algorithm that is best to solve a problem. So the kind of algorithm employed depends on kind of problems that you wish to solve and the number of variables, the kind of model, and that would suit it best, and so on. So here we're gonna see about the various learnings types that we have been through. So first we're gonna see about supervised learning. So supervised learning is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. So it infers a function from labeled training data consisting of a set of training examples. The supervised machine learning algorithms are those algorithms which need external assistance. So the input data set is divided into training data set and testing data set. So the training data set has one output variable which needs to be predicted or classified. All algorithms famous for his checkers playing program. So machine learning is used to teach machines how to handle the data more efficiently. Sometimes after viewing the data, we cannot interpret the exact information from the data. In that case, we apply machine learning. So with the abundance of data sets available in the demand for machine learning is in rise. So many industries apply machine learning to extract relevant data. The purpose of machine learning is to learn from the data, and many studies have been done on how to make machines learn by themselves. So many mathematicians and programmers apply several approaches to find the solution of this problem, which have been huge data set. So here in supervised learning, we will be having both training data set and testing data set. So we'll train the training data using a training model, and we evaluate that model using the testing data. So next we're gonna see about the decision tree. So decision tree, so we have been through, we have seen many decision tree types. So in the basic idea of decision tree is the graph to represent choices and their results in the form of a tree, and the nodes in the graph, so these are the nodes. The nodes in the graphs represent an event of choice, and the edges of the graph represents the decision rule or conditions. So each tree consists of nodes and branches, and each node represents attributes in a group, and it has to be classified, and each branch represents a value that the node can take. So this is the decision node, and these are the decision. So next we're gonna see about the naive Bayes. So it is a classification technique based on Bayes' theorem with an assumption of independence among predictors. So in simple terms, a naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature. Naive Bayes mainly targets the text classification industry. It is mainly used for clustering and classification purpose. Depends on the conditional probability of the happenings of the things happening in that model. So So next we're gonna see about support vector machine. So it is another most widely used state-of-art machine learning technique. And in machine learning, support vector machines are supervised learning models which are associated learning algorithms that analyze data used for classification and regression analysis. So in addition, this SVM performs linear classification, and it can efficiently perform a non-linear classification using what is called as kernel trick. That is, it implicitly maps their inputs into high-dimensional feature spaces. It is basically draw margins between the classes. The margins are drawn in such a fashion that the distance between the margins and the classes is maximum, and hence minimizing the classification error. So that is the advantage of using the support vector machine. And next we're gonna move to unsupervised learning. So these are called unsupervised learning because unlike supervised learning, above there is no correct answers and there is no training or testing a data. So here the algorithms are left to their own devices to discover and present an interesting structure in the data. The unsupervised learning algorithms learn few features from the data. So when new data is introduced, it uses the previously learned features to recognize the class of the data. So it is mainly used for clustering and feature reduction. So next we gonna move to principal component analysis. So this principal component analysis is a statistical procedure that uses an orthogonal transformation to convert a set of observations of possibly correlated variables into a set of values of linearly uncorrelated variables called principal components. In this, the dimension of the data is reduced to make the computations faster and easier. So it is used to explain the variance, covariance structure of a set of variables through linear combinations. So it is often used as a dimensionality reduction technique. So if we have to reduce the dimension of our data, so we will be using this principal component analysis. So next we're going to move to k-means clustering. So it is one of the most simplest unsupervised learning algorithms that solve the well-known clustering problem. The procedures follow a simple and easy way to classify a given data set through a certain number of clusters. So the main idea is to define k-centers, one for each clusters. So these clusters should be placed in a cunning way because of different location causes different results. So the better choice is to place them in much possible far away from each other. So next we're gonna move to the semi-supervised learning. So semi-supervised machine learning is a combination of supervised and unsupervised machine learning methods. So it can be fruitful in those areas of machine learning and data mining where the unlabeled data is already present and getting the labeled data is a tedious process. With the most common supervised machine learning methods, you train a machine learning algorithm on a labeled data set in which each record includes the outcome information. The sum of semi-supervised learning algorithms are task-exclusive SVM, generative models, self-training. So we will be seeing all these in all these descriptive methods in the next lecture. So next we're gonna move to reinforcement learning. So reinforcement learning is nothing but it's a very big it is a vast area. So reinforcement learning is an area of machine learning concerned with how software agents ought to take actions in an environment in order to maximize some notion of cumulative reward. So reinforcement learning is one of the three basic machine learning paradigms alongside with the supervised and unsupervised learning. So we're going to see this elaborately in the next lecture, and we're going to move to ensemble learning. So ensemble learning is the process by which multiple models such as classifiers or experts are strategically generated and combined to solve a particular computational intelligence problem. So ensemble learning is primarily used to improve the performance of a model or reduce the likelihood of an unfortunate selection of a poor one. So other applications of ensemble learning include assigning a confidence to the decision made by the model, selecting optimal features, data fusion, incremental learning, non-stationary learning, and error correcting. So here under this ensemble learning, we will be learning about boosting, bagging. So we'll be seeing what is a boosting, no? So the term boosting refers to the family of algorithms which converts weak learner to strong learner. So boosting is a technique that is in ensemble learning, which is used to decrease the bias and variance. So boosting is based on the question posed by Kearns and Valiant: can a set of weak learners create a strong learner? So there is a problem based on this boosting algorithm. So next we're gonna see about bagging. So bagging or bootstrap aggregating is applied where the accuracy and stability of a machine learning algorithms needs to be increased. So if we want to increase that stability of an algorithm, we'll be using this bagging method. So it is applicable in classification and regression, and bagging also decreases the variance and helps in handling overfitting. So next we're going to see about neural networks. So a neural network is a series of algorithms that endeavors to recognize underlying relationship in a set of data through the process that mimics the way how the human brain operates. So in this sense, neural networks refer to a system of neurons and either organic or artificial in nature. So neural network can adapt it to changing input. So the network generates the best possible result without needing to redesign the output criteria. So the concept of neural network, which has its roots in artificial intelligence, is swiftly gaining popularity in development of trading systems. So an artificial neural network behaves the same way. So it works on three layers. The input layer takes inputs, the hidden layer processes the input, and finally the output layer sends the calculated output. So next we're gonna see about this instance-based learning. So this instance-based learning refers to a family of techniques for classification and regression, which produces a class or class label or a prediction based on the similarity of query to its nearest neighbor in the training set. So in explicit contrast to other methods such as decision tree and neural network, instance-based learning algorithms do not create an abstraction for the specific instance. Rather, they simply store all the data and at the query time delivers an answer from an examination of the query's nearest neighbors. So this is how the instance-based learning works. So by this, we'll be concluding our lecture.